Right, guys, so for number one there, I did fill, and I also spoke about this one in the lesson yesterday, that angle will be 90 degrees because we have a tangent and a radius. So that is 90, which is angle ACO or OCA, doesn't really matter. And then you have three angles in a triangle there. So you can say 3A plus 2A plus 90 will be equal to 180 degrees because of angle sum in triangle. And then 3A plus 2A obviously is 5A. You then move that plus 90 over to the other side. 180 minus 90 is 90. And then you divide by 5. Are there any questions on that first one? All right, number 3. There was no number 2, so number 3 is the next one. For this one, this triangle on the outside is actually an isosceles triangle, right? Because we have two tangents from a common point outside the circle, and that theorem says that those two sides are then equal. So this is then an isosceles triangle. Oh gosh, I worked it out incorrectly. Oh no. Okay, so what is D then actually? Sorry, it's not 50. These two must together, they must add up if these three. So this is also going to be D, right? Sorry, so my values are wrong there actually. I'll fix them now. Okay, does that make sense what I filled in there? Okay. That theorem says that two tangents from a common point outside the circle are equal in length. So those two are equal. It's an isosceles triangle, so these two will be equal. So if that's 50, these two have to add up to 130 to make the 180. And what's 130 divided by 2? 65. Hey, sorry, I wrote 50 here. Okay, so this is actually 65 degrees. And my other values are also just going to have to change. I'll fix them now. So the reasons that you have to say there, guys, angles opposite equal sides, tangents from common point, and also I left out actually angle sum in triangle as well. Just make sure that you have those three angles. So those are the steps that we used to do quite often when you have the isosceles triangle because of radii. Okay, so where we would normally write radii, we now have to write tangents from common point. That's how we knew that it's an isosceles triangle. Sonia? I think they wanted you to do them in the reasons. No, it doesn't really matter. Sorry, I thought you were asking about the angles. I think they wanted us to do the angles in alphabetical order, but they didn't. Yeah, they didn't state that explicitly, so I think it's fine. I think that will be fine. Okay, so then E will also be 65 and F will then be 130. Sorry about that. Right, so I'll show you now on the picture. If D is 65, D is an angle between the tangent and that chord. And what we did yesterday is an angle between a tangent and a chord is equal to the angle subtended by that same chord on the other side of the chord. All right, so E will have to be equal to angle D. All right, so if D is 65, E is also 65. And then to get F, I just did angle at center because E is at the circumference and F is at the center. So F has to be double the size of E. So if E is 65, then F is 130 degrees. All right, number 4. Here we have that angle is 60. And again, this angle is between the tangent and this chord. Then this chord subtends angle G on the other side of the chord. So because of tan chord theorem, those two angles have to be equal. So G is going to be 60 degrees from there. Right, G equals 60, tan chord theorem. Then H is the angle at the center, where G is at the circumference. 60 at center will have to be 120 because we know that the angle at the center is always double the one at the circumference. So 120 degrees. And then for I, there were two things that you could have done. All right, and this actually happened quite often. You could have done almost like the old method that we used to do, where this is an isosceles triangle, right? If that is 120, then those two angles have to add up to 60 to make up 180. But because they're equal, we would say 60 divided by 2, so they're each 30 degrees. The reasons they would be angle, sum, and triangle, angles opposite equal sides, and then radii. But now, because we know that the angle, or that a tangent is always a tangent, sorry, this one is always perpendicular to a radius, right? So we know that that whole angle, angle OCA or ACO, is 90. Now, if that part of the angle is 60, what must I then be equal to make up 90 degrees? 30. Okay, so that's actually a quicker way of doing it. It requires less reasons. So this is almost like what we did in the past. It's still perfectly fine. You'll get all the marks. All right. But this is now a quicker way of doing it, where you know that that whole angle must be 90. And because you already have 60 degrees, the I part, the rest of that angle would have to be 30. And then you just need one reason. Now, guys, if you write more reasons, they're not going to give you more marks. Okay, they always award marks according to the shortest or the quickest way of getting to the answer. So this line will be 2 marks. So it will be 1 mark for the 30 and 1 mark for the reason. And even if you wrote this whole thing with 3 reasons, you would still only get 1 mark for the 30 and 1 mark for all 3 of those reasons. Meaning that if one of them is left out, you will lose that mark, unfortunately. All right, then number 6. So to get M, I use that method again, where we know that the tangent is perpendicular to the radius, or that the diameter in this case. So that whole angle there is 90. So M will then be 90 minus 38. All right, to get you M, which is 52 degrees, tangent perpendicular to radius. And then to find N and P, you could have used tan chord theorem for both of them, because this 38 degrees is between the tangent and chord CD. And then CD actually subtends 2 angles in the alternate segment on the other side of it. All right, so 38 degrees will have to be equal to N and to P. So you could have actually written N equals 38 and P equals 38 tan chord theorem. Or if you got that N is 38, then you also could have said now angles in same segment P is also 38. All right, so that's why I wrote 2 reasons there. Could have said tan chord theorem for both of them, or you could have said tan chord theorem for the one and then angles in same segment for the other. Are there any questions so far, guys? Yeah. Yeah, that's fine. Yes, with tan chord theorem as one reason. Yeah, that would be fine. All right, number 7 was a bit more difficult because you had to do like in between steps, and they didn't give you all the in between angles really. They didn't label them. So for 7, we wanted G here first. All right, so what I thought was, okay, this is going to be a 90-degree angle, right, because of tangent perpendicular to radius. So if I know what that angle is, I can just say G is 90 minus that angle. Now, do we see that this again is an isosceles triangle? So if that's 50, then that one will be 50, right? So for the reasoning part of that, you could have written that as a separate step. You literally could have said angle OCD is 50 degrees, angles opposite equal sides, and then radii. And then G will then be 40 degrees because it's 90 minus 50, right? For tangent perpendicular radius. I wrote it all in one line. Okay, so I said that G is 90 minus 50. This 50-degree angle is angle OCD. So it would have been fine if you wrote that angle first on its own in a line. And those would be the 2 reasons for that angle there. angles opposite equal sides and radii. All right, forgetting that that angle is 50. And then for saying 90 minus 50, it would be tangent perpendicular radius. Yes.
So if there are three things, then we take two.
It depends on how the marks are allocated. So if they've given one mark for all the reasons, if you leave one of them out, you will lose that mark. But usually they award more than one if there's more than one reason. Sometimes also it's a statement and reason mark where they give you one mark for the answer and the reason together. But that's usually if it's something that you've used a bunch of times before already, or if it's something very easy like vertically opposite angles, for example. They'll just give a mark for the answer and the reason. So yeah, it depends. Okay, then for the next one, for finding R, I decided to just work. I mean, there might have been other ways of doing it as well. Oh, I'm seeing another way now, actually, which would have been quicker. So do we see this exterior angle of this outer triangle? Right, do we remember exterior angle? That's also something that I always forget, but it's actually nice and quick. I remembered it here, but then I forgot it in the previous one. 50 degrees is the exterior angle of triangle ACD. Right, and what do we know about the exterior angle? It should be equal to the sum of the opposite interior angles. Now I have that G is 40, so what must R be? 40 plus what will give me 50? 10. Hey, so that actually would have been a one-step method. That would have been easier or faster than what I wrote down. I'll show you now what I wrote. But just again, guys, the exterior angle is equal to the sum of the opposite interior angles. So you could have just written that R is going to be 50, the exterior angle, minus 40, the one that we have already. Okay, so you would get 10. I worked with angle, sum, and triangle in the whole thing, as in this big triangle. Right, so that's why I wrote an in-between step there, so you can see I did a much longer method. I'll write in the exterior angle just now. So I first found that angle at the center, this one, COD, because if that's 50 and that's 50, then that one has to be 80. And then I said to find R, it's going to be 180 minus 80 minus 90 in this big triangle. I did angle, sum, and triangle there. Then you also get 10. Okay, it's much longer than the exterior angle one. So I'm just going to write that one in quickly. R would be 50 minus 40, which is 10 degrees. Exterior angle of triangle. You can see I used it in the previous one, but I didn't recognize it in number 7. Okay, let's quickly go through number 8. So here, that was an S and a T and a U. So I think I did the same thing as here, where I said that this whole angle would be 90, and that one would be 55, right? If that's 55, this one must also be 55, because again, it's an isosceles triangle. So that's what I did there. So I said S is 90 minus 55, because of tangent perpendicular radius, but also angles opposite equal sides and radii, for getting that 55-degree angle there. So tangent perpendicular radius, angles opposite equal sides, radius. So it's exactly the same as my previous question's first step. Then I used exterior angle of a triangle to find T. So like we just discussed, exactly the same setup here. The exterior angle is 55. So 55 should be equal to S plus T. All right, so T is going to be 55, the exterior angle, minus S, which we just calculated was 35 there. All right, so T is 20 because of exterior angle of a triangle. And then to find U, I just did tan chord theorem, because S is this angle between the tangent and the chord. So it will be then be equal to the angle subtended by that chord on the other side of the chord. Yes? Yeah, so you would have just had to calculate that one as well. So you would also have to say angle, sum, and triangle as your reason, or as a part of your reason. But yes, that would have worked as well. Mhm. They have to technically state that, but that's usually how the question is set up. But normally they break it up into like a 2.1, 2.2, 2.3. So they probably won't give you just a picture like this and just say find the angles. Okay, it will be more structured. Okay, guys, I'm not going to mark 9 and 11 now because I can see that, yeah, there's a big contingent that didn't do this work. Just on that, I'm getting a bit frustrated because it really is taking a lot of my time, and especially yesterday when I forgot to record the lesson, I had to spend my free hour at the end of the day when I had a lot of other work to do to re-record the lesson for you guys so that you could watch it and so that you could actually do the work. So yeah, I actually think it's really disrespectful for you to sit here with no work done when you know that I'm going to a lot of, I mean, other maths teachers are just telling their kids just read through the notes and do the questions. I'm the only one that's actually recording lessons so that you can follow along at home. So it's very upsetting actually. And if it carries on like this, I'm not going to keep doing it because it's taking 20 extra minutes per class for me to convert the video, take pictures of all the notes, put everything up. And then for some of you to just sit here with nothing done, it's very disconcerting. So please. And I mean, like I said already, if you don't do this work now, I'm not going to do it again next year. And this section is a big part of your matric finals. So if you're not doing any work now, you're already scrapping maybe 40% of your matric final exam, because that is the section. This section is big. And I know I'm speaking to the minority. I can see that many of you are working along and you are doing work at home, which is great. But yeah, please don't disrespect me like this anymore. Okay, you're going to do 9 and 11 of this worksheet if you haven't done it already. And then I'm adding questions from the textbook. Okay, so you're doing these two. And those questions, please, from exercise 6 in the textbook. So in all of these questions, you are still working with values. So on Monday, we're going to do examples with just x's and so on, where you have to prove certain things. So that will be Monday's lesson. And then we're actually done with all the content, guys. I've actually taught you all the theorems that you have to know, but we haven't done any of the proofs yet. All right, there are 5 proofs that you have to know. So we're supposed to finish circle geometry on Thursday next week. So I think Monday I'll maybe go over the grade 10 ones, which you have done already. And then Tuesday, Wednesday, Thursday, we'll do one on each day. Okay, so that it's not an overload. But that is another thing that we must remember. You can be tested on proofs as well in your test that's coming up. Did you guys all see the notice about the test? So that second test, I know that there is a date on Google Classroom, but it might still change. It probably will change. We probably will bring it a bit forward because marks actually due on the day after the test. So the 21st is a bit late, but we're kind of just waiting to see if everyone will be back at school. Then it will be easier to just test during class instead of with an after school thing.